Hello my dear students. So here is question of the day 1. Today's topic is a thermal expansion, right? So this week we'll do all good questions of thermal expansion and calorimetry, right? So these are those topics which are actually easy but very scoring for JEE Advanced or JEE Mains exam, right? So we have to focus on these areas, small areas also are very important, right? So today's question is very important and generally students feel problem in this question, right? Because theory part of this question is not there in any good standard book, right? That's why this question is very important. So first see this question properly, beta. So this question I already have discussed in my class, right? But yes, try to recall the concept of this question and try to solve it. Okay. So the question I will read for you. So 3 rods and a spring of stiffness constant K are arranged in a series between fixed supports as shown. So first of all, these supports are not fixed. Okay. And temperature of the system increases by delta T. So this system is in the horizontal plane, right? And temperature you are increasing by delta T, right? So here I should write that system is in horizontal plane, right? Okay. And then we need to find compression in the spring, right? Obviously in equilibrium. So when you are increasing temperature by delta T, then what will be compression in the spring, that we need to find. Okay. And what we are assuming thermal expansion of spring negligible in comparison to rods, right? So it means that alpha of spring is very less. So when you write delta L is equal to L alpha delta T, that formula when you write. So more is the value of alpha, then more will be the expansion due to rise in temperature. So alpha of spring is very low. It means thermally it will not have any effect on the spring. Okay. Now for all the 3 rods, some of the physical quantities are given, like Young's modulus, cross-sectional area, length of rod, and coefficient of thermal expansion. So these 4 things are given for each and every rod, rod 1, rod 2, and rod 3, right? Young's modulus, area of cross-section, length, and coefficient of thermal expansion. Okay. And spring constant K is also expressed in terms of YA and L. So that data is given to you. Okay. And what is required in the question? We need compression in the spring. That is what we need here. So pause this video for at least 2 minutes, right? For 2 minutes, 2 to 3 minutes you can give to this question. So try it for 2 to 3 minutes and see whether you are able to solve it or not. Okay. Right. Okay. Now let's discuss detailed solution of this question. So here first of all what we need to think. So here what we can observe, it is in horizontal plane and it is in equilibrium. So horizontal force at each and every point should be same, right? So force for rod 1, 2, 3 as well as for spring, it should be same. A common force should be there. Okay. Okay. So first we should try to find that common force. So what can be this common force? Okay, so that should be our approach. And brainstorming angle, or that you can say crux point also, right? So that whatever is the expansion in the system thermally, that has to be magnified by mechanical compression, right? So net thermal expansion should be equal to net mechanical compression. So that is the very crucial point of this question. Okay. So thermally what will be the expansion of each and every rod that I am writing, right? L alpha delta T for each and every rod, like for first rod, right? Length is 2L, coefficient of thermal expansion alpha, change in temperature delta T. Similarly for second rod I am writing, and for third rod I am writing. It should be equal to mechanical compression. So this mechanical compression, how I am writing it? So I am applying Young's modulus formula. Y is equal to stress upon strain. That is stress upon strain. So delta L, change in length for any particular rod, I can write like this: FL upon YA. So that is the formula of extension in any particular rod. So like first rod extension compression should be this, FL by AY. For second rod, that should be the compression. For spring, what should be the compression? F by K. And for fourth rod, that should be the compression, FL by Y into A. Right, bete? So I am making these two things equal. So what I am getting? F I am getting that common force. So this force is common for all the four things, three rods and spring. So this common force I am getting, right? Now after getting this force, what I need here? I need compression in the spring. So I can write this force is equal to Kx. So X I am writing F upon K like this. Okay. So this I am writing. Okay. So finally I am getting, since K is given YA by L. So if you substitute here K as YA by L. So what you are getting? 18L alpha delta T by 13, right? So you can check my calculation. If I have done any mistake, then please write in the comment section. Okay. And also, if any step is not clear, then also please write. Very important question. Sometime in these types of questions, they ask to find potential energy stored in a spring. Like in case of one spring, they are connecting two springs. No problem, right? So concept of the question will remain same. So concept is same only, right? So they are saying like two springs are there, three rods are there, right? So question can be anything. They are asking potential energy stored in the spring, half kx square, right? Like that. Okay, beta. So like this we can solve this question, right? Okay, so tomorrow I will bring another question like this of this topic, thermal expansion and calorimetry. All good question of these topics I will cover this week. Okay, right? Okay, thank you.